Good morning. My name is Andrew Femright, broadcasting here from the beautiful CU Boulder campus. Today actually looks a lot like it does in this slide outside, but we're here indoors to present a few interesting aspects of our professional master's programs to you. So I am the faculty director for the Electrical, Computer, and Energy Engineering Professional Master's Program, Embedded Systems Engineering. I'm going to speak a little bit about a couple of other professional master's programs as well today, but I'd like to start with first explaining what a PMP is. What is a professional master's program at CU Boulder? About 5 years ago, CU Boulder launched an initiative around professional career preparation to focus on highly employable disciplines and skills based on industry needs. They commissioned professional master's programs for our colleges to adopt with their respective curriculum. With most students pursuing terminal degrees and then planning successful industry careers, PMPs are emphasizing the doing that follows the critical thinking in a sense. In other words, PMP curriculum emphasizes practical hands-on curriculum that is supported by all the theory in the preceding curriculum that most students have. The College of Engineering and Applied Science has fully embraced professional master's programs with over a dozen professional master's programs to date. And our department, the Electrical, Computer, and Energy Engineering Department, has currently 3 professional master's programs in various stages and more to come. So let's dive in briefly to a couple: power electronics, photonics, and I'd like to spend most of the time on embedded systems engineering. That's my area of expertise and the program that I've established and run primarily for the past several years. So first of all, power electronics. We provide several in-depth graduate courses in 3 main areas. But the core courses have been with the department for many years, offered by tenure-track faculty that have very long credentialed histories in academia, and some very strong lab courses that are attended by several undergraduate and graduate students here in the University of Colorado Boulder. Over the past couple of years, a lot of distance options have been added to these courses as well as soon to come near on-demand offerings through Coursera. In fact, the Introduction to Power Electronics, the ECN 5797, is currently offered on Coursera as a complete specialization. I would encourage you to check that out. The 3 main areas of our power electronics professional master's program: electric drivetrain technology, several courses; next generation power systems, as well as integrated circuit design and power management. So throughout these options, you have plenty of curriculum for completing a professional master's degree. Oftentimes, though, students take a majority in these areas, but also take advantage of other courses throughout our department and other departments. Professional master's programs typically reside under existing Master of Science or Master of Engineering degrees, and therefore are subject to those degree rules, respectively. Typically, the PMP program has core and elective requirements and that are specific to the program, and also allows you access to other curriculum, as I mentioned, throughout our department and throughout the college, other graduate courses in your areas of interest. Okay, so photonics. Our photonics professional master's program is the newest. It'll be effective this fall. I think we've just admitted our first cohort of full-time grad students. And here our department seeks to balance an area of strength that has long been with the department. A lot of research, deep research going on in photonics for many decades, actually. So these courses are offered they span photonic skills, optical core, electronics core, and several current applications courses. I would encourage you to check out more details on the photonics and the power electronics professional master's programs on our website, which will be provided at the end of this presentation. All right, so moving on to embedded systems engineering. By now, most of you who follow electronics or technology have heard of IoT, right? The big IoT catchphrase, Internet of Things, which is really an enormous megatrend of all things widget becoming somehow connected to the internet by some magic, right? Behind all that, though, these widgets are still effectively embedded systems. An embedded system is merely an intelligent electronic device or system dedicated for a single purpose, like your microwave, your car stereo, or your heating and ventilation, air conditioning system at home, or in a commercial installation, etc. Anything that runs on power, be it battery or wall power, that has an intelligent electronic system inside of it is an embedded system. Today there's increasing motivation to connect these things through intelligent means through the internet so that users can access them remotely, control them remotely, or machines can actually talk to other machines. That's not just science fiction anymore, as most of you know. All right, so based on very clear demand in the industry and this trend of IoT, we're pleased to now offer a full, what I refer to as a full spectrum of curriculum. When we started just a few years ago with our certificate, we had a handful of courses that had been offered for a long time in the department, very successfully. Many students locally have experienced the embedded systems design and the real-time embedded systems courses. But this opportunity of IoT gave us a great chance to expand our curriculum into enough courses that really do justice to all of the topics in embedded systems. So that is our intent here, is to really broaden and offer complete embedded systems curriculum on purpose, as I like to say. So in a word, comprehensive, rigorous, and balanced embedded systems coverage. All the major end markets and technologies being addressed as we expand the program. So spend a few minutes here. So around the fringe of this slide here, you see several faces. These are current tenure track and industry instructors. As with most of our professional master's efforts, we seek to balance our research and tenure track faculty expertise and deep knowledge with industry expertise. So we're bringing in those who have deep experience in industry, who understand what current applications and needs are driving these trends, and helping us to build the underpinnings of all of these courses. So along the left-hand side and on the right, you'll see course names. Hopefully you can read those. There will be, you'll find the same ones on our website as well. But as you can see from the long list on the left, a lengthy core, embedded systems core offering. And on the right are program electives. The program requirements today involve 5 from the core for graduate degree, and 2 from embedded systems electives. That leaves you 3 of the total 10 courses for a degree to branch out into other areas, as I mentioned earlier. So I'll touch on our certificate as well for those of you who are just interested in increasing your knowledge in these specific areas. 3 courses required. Many of our students are industry professionals who come in and take just these 3 courses. So 2 of these 3 must be from the set of embedded systems design, real-time embedded systems, and mastering embedded systems architecture. You have your choice. And then the third could be an embedded systems elective, or you could take all 3 of these courses as well and meet the requirements for the professional certificate. I really want to talk a few minutes about some of the operational aspects of our program. I think they truly differentiate us from most or all other universities who offer embedded systems programs, and certainly there are a number of great ones out there. First of all, we have one of the most extensive list of course offerings, and more to come. I'll touch on those as well in a few minutes. Currently we offer all core courses twice a year. I haven't found that to be true anywhere else. So oftentimes students engage with a program or university and they find that they can't take the curriculum when they need it or want it, we've solved that problem, I believe. So it also offers great flexibility, right? Most students don't take 8 core, but you have 8 and more to come to choose from. And most of those are typically offered both fall and spring. A couple of them are offered spring and summer. We've pushed our schedule into the late afternoon or evening as well to hopefully accommodate those of you from the industry who can find a way to adjust your schedules and take courses later in the day. Or, as I mentioned, the distance options also offer, captured lectures, recorded lectures that you could access soon thereafter if you happen to miss one or two. These are obviously industry-driven topics. We have an industrial advisory board that we present all this material to in depth twice a year and get their feedback on whether or not it's relevant, whether more topics are needed that we may be missing. We're also providing support for most of our courses with 2 teaching assistants. And the class sizes are typically in the 15 to 30 student range. There are a couple that are larger, but that's usually what the range is. So the instructor and teaching assistant ratio to student is quite high. Development kits for the program are provided. Each and every course in the program typically involves several mini projects, and therefore development kits for writing software and developing hardware. I think the rest speaks for itself there. The list of courses, as on the previous slide and also on the website, the ones in the middle of the slide here are the newest that we've added in the past academic year, and I'll give you a preview here in a moment on more new courses to come. So this fall, we're introducing 2 new courses: Advanced Practical Embedded Software Development. There's a fundamental course, Embedded Software Essentials, now referred to as Principles of Embedded Software, that basically goes through all of the fundamentals of embedded C programming and all of the dependencies on embedded systems that you need to know to be extremely competent in that area. But it's not enough to cover all the other topics of embedded software that need to be touched on, such as embedded operating systems, Linux, bootloaders, kernels, device drivers, etc. They just don't fit in one course. So we are adding another one this fall. It's already very popular with students, and we may be expanding the capacity on that course in the near future, just out of the chute. The website for that is not up yet, so please stay tuned to our Embedded Systems Engineering homepage for updates on that. The second course being introduced this fall is Practical Printed Circuit Board Design Manufacture. This course actually will involve 2 aspects. There'll be a 5-week boot camp, if you will, if students wish to attend only that piece. Learn how to design basic 2-layer PCBs correctly the first time, and then we'll go on into much deeper topics through the rest of the semester on complex multi-layer PCB design and some very practical aspects of doing so. The spring semester, we're going to introduce a new course in application-specific IP and IP core processor design. Imagine being able to design your own microcontroller architecture and then enabling other companies to adopt that architecture very quickly. So it's IP implement or integration is also a challenging topic that's covered in some of the other FPGA, field programmable gate array courses that we offer, but this one goes beyond that into a newer technology referred to as ASIPs that allows you to create your own IP and enable others to use it. All right, so I think I touched on the core and elective requirements. Back in fall of 2015, when we launched our Embedded Systems Engineering program, the requirements were lighter because we had not introduced as many courses. But now, having introduced 8 new courses and another 3 to come, there's more than a large enough palette to increase these requirements. When we invite students to join our program, we intend to send them away with highly competitive skills and knowledge, enabling them to compete very well in the global marketplace. It's worth mentioning, if you do have a moment, you could Google embedded systems engineering and find that we're the #1 educational institution beyond the ads, the ad search results. Thanks to our grad school for providing the visibility to us in that manner. So it is a quick way for you to find us if you miss the website here at the end. Just Google embedded systems engineering, and you will find CU Boulder very quickly toward the top of this list after the ad results. So just a few items, and we'll get into some Q&A, hopefully. A few of you may have questions. So embedded systems is certainly one of the broadest professional career fields. Every end market that I know of involves electronics and requires some sort of embedded system in order to enable its productivity and success. So that's on Earth here, below the Earth, above the Earth, in space, everywhere. Embedded systems is literally, they are literally everywhere. Our department, therefore, has to offer as broad of a program as possible to cover those topics, enabling students to pursue careers in nearly or any end market that they choose. So our program is a complement to some of the more deeply theoretical courses. We focus on project-based, non-thesis, industry career topics and projects to prepare you for those opportunities in the industry. Our websites are at the bottom of this page, both for our department and our degrees and programs. I hope you go there and find much of the information you need, but right now I'd like to try and answer a few questions, if you would. Do we have anything queued up? No? No questions queued up? Give it another moment. Okay, one question I'm told.
Are the requirements listed on the admissions page hard requirements, for example, GPA and GRE?
Are there...
you want me to read it?
Yeah, go ahead.
The question is, are the requirements listed on the admissions page hard requirements, for example, GPA and GRE? All
right. I think, are these requirements hard? No, not necessarily. They are strong guidelines, however. Any students not, I guess, I'll say candidly, not approaching those requirements may want to consider not applying, but we look at far more factors than just those when reviewing admissions credentials. We look at a variety of options or aspects such as what's in the statement of purpose for the student, how much of an embedded background for specifically the embedded systems engineering program, how much embedded experience, both academic and industry, they have. This is a fairly rigorous program. We're not able to go back as far as some of the electronic circuits basics or C programming fundamentals. We're expecting students to have a pretty good base of those coming in. So credentials listed on our website are strong guidelines, but not hard requirements, I would say.
Another question. Generally, how long do one of these programs take to complete?
How long do these programs take to complete? So start with a certificate. A certificate in, I think, most or all cases for our department is 3 graduate courses. Of course, it's a semester. The flexibility of and the frequency of those offerings provides students with the ability to finish, I think, in 3 semesters or 3 terms. Sometimes that term is a summer, or less, depending on your workload. If you're a full-time student, you could, in theory, finish in 1 semester. If you're working part-time, it's probably 2 to 3 terms. For a full degree, that's 10 courses. So you can do the math again on whether you're a full-time student or part-time. Most of our graduate students work part-time and therefore take two or three courses per term. So most of them are completing their degree in three or four terms, depending on how many summer courses they're able to intersperse. Okay, so simple answer, 2 years or less for a full degree. Sure. I'm sorry. Adam Sadoff here off screen with me. He's our graduate advisor for the Electrical, Computer, and Energy Engineering Department.
I would add for those currently working, living, or studying in the United States, Mexico, Canada, or Central South American countries, some of those may study via distance learning, and we may expand that as soon as fall 18 to many more countries. But those people who work full-time are encouraged to solely enroll in one course each semester due to the extreme workload involved both in a full-time job. Bosses tend to unexpectedly give a heavy workload to their employees, and taking just one of these courses is quite sufficient. Full-time students on our campus, the minimum requirement is just 2 courses, and 3 is quite manageable. Anything beyond that gets a little bit challenging given the content of the coursework. I do have another question here.
Okay, another question.
It's come in, and that is, can we transfer credits from online courses to a regular course afterwards?
Can we transfer credits of online courses? Let's first assume they mean our own online courses. So yes, the credits for online sections of our courses are considered equivalent to the campus credits. If you're referring to online courses from other universities, I'll defer to Adam on that one.
And the answer is yes to that as well. As long as they're technical, math, science, or engineering, maximum of 9 course credit hours, semester course credit hours can transfer in toward a master's, and up to 21 towards a PhD. However, we're talking just professional masters here, so that limit would be 9 semester course credit hours.
Okay.
Another question has come in. Are all the courses for power electronics offered in each fall and spring?
Are all the courses for power electronics offered in fall and spring? I think the short answer is no, although a majority of them are. That's the best answer I can give you off the top of my head. Please refer to our website for further details on that. Or you can email Adam Sadoff or myself, and I will direct the question to an appropriate faculty member. Okay. Any other questions in the queue?
Another one. Are all the courses for embedded systems offered in each fall and spring?
Okay. Great question. Are all of the embedded systems engineering courses offered each fall and spring? Short answer, no, but the vast majority are. In fact, almost all of them are. The core courses on the list are offered both fall and spring, with one exception that I can think of. It's real-time embedded systems. That one is offered spring and summer. Again, all core embedded courses are offered twice a year, one way or the other. So most of those, or almost all but one, I think, are offered fall and spring. The electives in embedded systems are offered at least once a year. There are 1 or 2 that are offered more than that. Hopefully that answers that question as well. What other questions? Okay, seeing no further questions in the queue, and we're just past our time. I appreciate everybody. Oh, one more? Yeah?
One more.
Okay, good.
How is the process of inscription and cost of the distance electronic power program?
Cost?
I'm not sure about the exact meaning of the first part of the question.
I'll take a shot at it and refer student prospects to the bursar's webpage on tuition costs. That may be what you're after. There is quite a bit of detail there, and I believe the 2017, 2018 tuition rates are now published. So please search colorado.edu for the bursar's website on tuition rates, and you should be able to glean most or all the detail you need there. You'll look for the column on professional master's programs in the College of Engineering.
2 more questions. 1, is there funding available through the department? And 2, is it possible to contact you via email or phone?
Funding through the department, short answer is yes. There are a couple of avenues. I believe there is a financial aid contact on our website that you should pursue for, that's one avenue. We do offer a number of our students student assistant and teaching assistant positions based on their academic success here in the first semester. Typically and very candidly, student assistants, TAs, are selected from the best students of a course to carry those duties forward the following semesters. And in fact, the department is planning to provide some financial aid to all professional master's students with respect to the current rates. Am I reachable by email? Yes, I do respond to email over the summer. And so you're welcome to send queries, and I can direct them or answer them directly. andrew.femright@colorado.edu. You can find me on the faculty page as well. All right? One more. Okay, we'll take this as our last question.
Do the PMP power electronics students get to work at NREL after the completion of the master's?
Do power electronics students get to work at NREL? I'm sure some of them will. I don't have specifics. What I will say is that the industry partners that we've involved in all of our professional master's programs also have selfish interests. They're looking for great talent from the program, which stands to reason why we want their input into the program's curriculum, right? If we're able to provide what they need, then yes, I would expect them to be willing to hire our students immediately with their job openings. I'm sure they would have a preference for that. I don't have any specific examples of students who have been hired by NREL, but it's likely that they have. There are quite a few industry players for embedded systems as well that have hired our students for many years and continue to do so.
Comment on NREL. As best as I know, quite a few of our students have been hired periodically over the years through NREL, both masters and PhDs, and I believe through the professional power masters, there might even be some opportunity to do some internships there while earning the degree.
Yep. Both industry internships and careers are of interest to our partners.
We should speak with power faculty for specifics about that.
Yep. All right. So quite a few great questions. I appreciate that very much. Thank you for joining us this morning. Hope you all have a wonderful day and the rest of the weekend, holiday weekend here in U.S. Thank you very much.